possible to avoid creating reference cycles in your program. And if you happen to find them in your application, you have to explicitly delete them. So GC module allows you to see what all reference cycles are there in your program, and if you are sure that it's safe to delete them, you can just call gc.garbage. So garbage is the list that has all the reference cycles that are unreachable but uncollected. Then there is a concept called slots. So for every instance variable of your class, all the attributes are kept in dictionaries. So say if you have very few attributes and very few instances, so dictionaries could be an overkill. So slots allows you to store those attributes in the object itself, rather than keeping a separate dictionary per instance. So with that, you can save some more memory. These are the references that I have used for collecting the information and doing my experiments. I liked OBJ graph tool a lot. Actually, it itself can be an independent talk. There are so many things to explore in that. So if you get interested, you can take a look at that. And Python VM allocator code is also very interesting. The comment section itself is quite self-explanatory. It would be good to take a look at that. You can contact me. That's my email ID. Thank you very much. So if you have any questions, please let me know.
Hello, thank you for a wonderful talk. I just want to know how an empty dictionary and a dictionary with 2 elements was showing up the same size. I couldn't get you there.
Okay, so containers like lists or dictionaries, they reallocate a lot of memory. Hello? So containers like dictionaries and lists, they reallocate a lot of memory. So actually allocation has already happened. By the time you store the data, the memory is already there. So 136 byte is the overhead plus the extra space that Python VM has allocated for dictionaries. So that's why size looks the same. Yeah, it keeps on expanding. It's like realloc in C. So you keep on reallocating the memory.
Yeah, hi. I wanted to know that you had mentioned that one part about the tuple, right? You said that the tuples are, immutable, but then you said something about them being mutable, right? Could you move on to that slide and explain it again? I couldn't understand it.
Sure.
Yeah,
yep.
That one.
So see, both the tuples, they have same value, A and B. But I concluded that they are behaving like mutable object because address of both the tuples are different. Look at this. So if addresses are different, they don't share references to each other. So actually they are 2 separate copies in Python VM. Any other question?
So is there a way to prevent GC? So the use case is we have a Python object that we are passing to an C extension, and before the extension uses it, it gets GC'd. So
I could not understand your question. Could you please repeat?
So we have a Python object that we need to pass to a C extension,
Okay.
and the C extension is going to do something on it. Before the C extension gets a chance to run, the object is GC'd. So the C extension refers to bad memory. So
Okay.
so is there a way to get around this?
Actually, there is a good programming practice that anytime you write your extension, and if you are creating an object that would be used in Python as well, so never use malloc. Use imalloc. Actually, you have wrappers over these functions. So if you use these wrappers, Python VM would have an idea who has allocated the object and how much memory it has available. In that case, actually, it will PC will keep track of those objects as well. But if you create it through bare APIs like malloc and free, it would have absolutely no idea of those objects in your extension modules. Did I answer your question?
Can you elaborate about memory allocation of list? Because basically, if we do an append in the list, it is going to be a lot faster than just inserting at any index, right? Meaning it needs to keep on indexing objects even if it is going to be added at any point.
Okay, so allocation of list is quite interesting. So every time you create a new list, so Python would reallocate memory for few of its objects. See, list is, you're not audible. Hello? Yeah. So list is a container, right? So it doesn't stores the object. It keeps references to those objects. So I found that for say n number of objects, Python will allocate the memory. So every time you keep appending, it would be very fast. But as soon as the memory for those n objects gets exhausted, it will do a realloc, and it will allocate exponential of the previous memory size. So say if earlier we had allocated 4 objects, it would now allocate 8. It would allocate memory for 8 objects. So this way, Python keeps on exponentially expanding memory for lists. So sometimes your append could be faster if the memory is already there, and if you happen to be at a time when memory gets exhausted, then it would be slow. So yeah, anything specific you want to ask? Okay. If it okay.
So how a list actually allocates details? Meaning it is going to keep a reference count as well as reference of the objects which are being stored, right?
Right.
How the reference is going to be calculated and how it's different from dictionary?
Oh, okay. I am not actually aware about the actual allocator implementation of list and dictionary. I'm not really sure about that. But I know how does it allocates memory for each of those objects. But implementation, I'm not sure.
Okay, thanks.
Yeah. Comprehension, I mean.
Could you comment about list comprehension, dict comprehension in terms of memories and performance as if I use a regular?
Okay, on a very high level, if you see, these are containers, list or dictionaries or sets or tuples, all of them are containers. Comprehension wise, as such, I see that dictionaries are more expensive. Dictionaries and sets have been found to be most expensive in Python VM. Lists are still cheaper when we see the object sizes. But other than performance, I don't see any other difference. I am
doing a comprehension and making a dict using dict comprehension and having a regular assignment on a dict.
I think I'm not sure
as in
about
like a lambda, using a lambda function or doing it in line, like in one line we make a dict, right?
Okay, I'm not sure about that. Sorry.
So last question.
So, people like me who deal with web applications, like we write web servers, at least I had the impression that objects are really cheap. So for like every request, I'm creating a new object. So for like a high performance stuff, do you recommend doing micromanagement of like removal of such objects? And I also have like a similar question. So do the thread locals, once the thread is over, are they like garbage collected instantly? So to save all this, because if I'm doing a request in a thread, suppose for every request I'm making a new thread, and all the request specific stuff I'm storing in the thread local. So is it guaranteed that that will not like bog in the memory or something?
Okay, see, here are two important things to keep in mind. First thing is, for any application where the average memory consumption is much lesser than the worst memory consumption, in that case you should do micromanagement. So if you know the peaks where your memory allocation patterns hits the maximum RAM, or actually it goes out of that, when your application starts hitting memory error exceptions, in that case you should start doing micromanagement, as I discussed about deletion of uncollected reference cycles or deletion of object explicitly. Then the other question, what did you ask? See, that too you can tune. So GC module, it allows you to determine the frequency of object collection. So you can set how frequent you want that collection to be happening. So that's up to you.
So we have time for one last question.
Thank you very much. Thanks for your time. Oh.
Can you explain the use case of using Python slots?
Pardon me?
Slots. You mentioned one.
Slots.
Yeah.
Okay. So Python allows you to create user-defined objects, right? Like classes. So every object has multiple attributes. These attributes are stored in dictionaries by default. So every object has its own dictionary. In that dictionaries, these attributes are stored as a key value pair. Now, if you know that you have very few objects and very few instances, in that case, maintaining a dictionary per object is quite expensive. So rather than keeping a separate dictionary, you can actually store these attributes in the object itself. So if you use slots, Python VM allocates some more memory that could accommodate these attributes in the object itself. So that's an optimization that you may want to go for if you are really running low on memory.
And that answers. Thank you.
Thank you very much. Yeah.